Hello guys, welcome guys. Hold on Okay, welcome. So today we're going to do nozzle offset calibration using the camera in Thai. Don't know whether you guys can see. This camera comes with the Z probe. So we can do all the calibration in one using one tool, but we have to do the XY first using the camera, and then we do the Z calibration, tabi Z using the Z and stop port. So let's turn on the printer first. Hopefully everything goes smooth today. We do the calibration, nozzle calibration, and then we can proceed to print. Maybe we run PID tuning first, then we do input shaper. We try input shaper, we do PID tuning, and then we will try to do a test print. After the nozzle, if got time, we do a test print. Yeah. Let me try to zoom first for you guys so you guys can see. Okay. Let me open up. Let me make this screen bigger. Hold on, so that you guys can see. Yes. Okay. Okay, we let us home first. Let us home the printer. Okay, I already put everything. Tool 0, tool 1, tool 2. All the config I set up. I think in the last stream we already do for T1. So we no need to do all that. We will do straight away. I will demo all the 3 tools to change first. Hopefully no problem. I already do a batch test, maybe about 20 or 30 batch tests only. Because just to get it working. You see whether it's consistent enough, and we see whether there's any problem. Okay, let's do a batch to change. Let's do a random to change of 15 here, so that you guys can see. Hopefully the tool change all goes smooth, no hiccups, no anything, and then we can proceed to do the camera calibration. I did reduce the speed of the Z and X steppers. I did reduce the speed to 400. Previously, the tool change was at 450, but a few times when it's trying to go up, it seems to miss some steps. So I think maybe this motor is not strong. This is cheap motors. I'm using the cheap motors for the two X and Z steppers. Okay, after this batch finish, we will do the nozzle calibration. Wait, I forget to hold on. Okay, so I already done this. So now what we need to do, let's fix the camera. I got a USB extension here so that we can plug in the camera to my PC. Let's plug in the camera first. Hold on, yeah. Okay, the LED is not soldered properly. Okay, now we need to open this software. Hold on, yeah. Let me put it in the screen mode. And then let me turn on PC mode so you guys can see. Yeah. Okay. We need to open this file, Mata V1.3, because this one is this is the file that Yoku from our Discord channel did to do this entire calibration, the nozzle calibration. So we just double click this file. You would open up here, we select our camera. Okay, my camera is not inside here. Let me try to connect again. Camera is not coming out here. Hold on, yeah. Why is the camera not showing inside? Okay, let me try to connect this camera again. There's no HD camera. Try this side. Hmm. Okay. I got the camera already. Okay, so you open up the file. Now you can see here. Connection, local PC, USB, camera 1. So camera 1, okay. So let's see. Yep. Camera is working. So this one you can see here. Open your clipper dashboard on the other half of your screen to control the printer. So we try to open up split screen this way, yeah. Then we can scroll up here. So start step-by-step guide. Home your printer and perform Z-tilt adjust or quad gantry level. I think we already home the printer just now. We already did, okay. That's no problem. Next step is place in tie on the bed. Raise Z height slightly above the camera lens. Okay. Raise Z height slightly. I will use my phone. You can use this way or you can use my phone. Since I'm here, I'm going to use my phone. So let's move this. We're going to move it. Hold on. 192. Let's move it higher. Okay. Now let's move it under. Okay. Wait. Why am I, hold on, I got disconnected. Okay. All right. Okay, so we follow the steps here. Place in tie on the bed. Raise Z height slightly above the camera lens. Okay. Using T0, move the tool manually until the nozzle orifice is centered on the crosshair. Okay, let's try to move it left. Oh, so this way, this side, move by 0.1. 108.68. Okay, let's try to move Y. Alright, I think this looks a bit okay. Need to increase Y a bit, maybe 123.62. Oh no, 123.58. Yes, this looks quite center. Okay. Okay, let's take down the coordinate. This is my tip on how. This is my tip on how to do it. My tip on how to do my way of doing this calibration. So you take these coordinates here, x 108.68 and y 123.58. We can ignore the z first. Okay, 108.68, 123.58. Okay, so once you get this, what you do is you draw off T0 and then you pick up T0 again to see whether the crosshair move to the center reliably or not, whether it's consistent on the center. Because sometimes when you do a tool change, your camera tends to move. The camera tends to move. Let me try to clip, see whether I got any clip to clip this cable. I got no clip here. Oh, here I got. Let me try to clip the cable so that the camera doesn't move. Because sometimes the camera move. The camera move and you do a tool change. Okay. Now let's do draw off of tool. Then we pick up again, okay? Then we pick up again. 20. Then now what is the Z at? I forget the Z at. Is it at 33? Seems like 33. Let me see. Yeah, could be 33. I see like it's 33. And then the X is 108.68. Y is 123.58. Okay, now we see whether is it correct. Okay, you can see that the crosshair has moved. I think we have the wrong Z. Let's move it up again. Okay, 38. The Z is at 38. Or is it 39? 38 just now. The crosshair is almost a little bit consistent. Let's try to move the X 108.66. Oh, wrong. 108.7. 108.72. 0.71. Yes. Okay. So 108.71. The Y stay the same. 108.71. 108.71. Okay, so we try again, yeah. Do a tool drop and then pick up again. Then we pick up again. And then we go to the exact same coordinate. X, we go Z first. Z just now is at 38. 108.71. Okay. Okay, X has moved a bit again. Let me try again. I think the camera is moving. Okay. Let's try 108.68. No. 108.72. 74. 76. 75. Let's put 76, right? Then 7. 108.7. I think 0.71 is quite accurate. 108.71. Camera is at 38, right? Yeah. Z is at 38. 108.71. 123.58. Okay, let's try again last time. Z is at 38. Okay. So we do tool draw off and then we tool pick up again. Z is at 38. X is at 108.71. Alright. I think the steps is moving. If I change here to 7.5, let's say 7.4. Move 7.5, 7.6, 7.4. Okay, we try 108.74. Okay, let's try again one last time. See if we can get consistent or not. Pick up again. Z38. 108.74. Alright. So it's pretty consistent now. 108.74. Okay, now we pick up. Okay, this one is finished. Next step, record the XY position. You can use get post. There's a get post position, I think. Oh, no more. Where's the button? Not the button. Oh, only if you are connected via IP. Okay. And then next step is drop off T0 and pick up the next tool. Okay, now we pick up tool 1. Let's see whether it will go to Z38 or not. I don't know whether it will it stay here or not. Try, ah. Oh, okay. It never go down. So we go to Z38. Now we will go try 108.74. 108.74. Okay, now what's the next step? Move T1 manually until the nozzle orifice is centered on the crosshair. Okay, let's move left. Oh, move right. Move left a bit. 110.16. 18. That's now 14. Okay. 110.18. 110.18 in X. And the Y is 123.98. Z is still 38. Z we don't need to take first, but we must remember this. Just put here 38 first, so that we don't forget. Okay, let's try to draw off T1 and then move back to this coordinate here. Let's see whether the crosshair is still at the center. So for this, we will do a tool draw off tool number 1. And then we do a tool pickup tool number 1. Okay, let's go back to Z38. 110.18 in X, 123.98 in Y. Okay, correct. Okay, again the X shifted a bit. I think the belt is not tight evenly. Yeah, I think could be the belt is not tight evenly, but never mind lah. Just leave it. 0.9, 0.2, 22, 110.22. Okay, let's try. 110.22. 110.22. Okay, we draw off again. Then we pick up again. 110.22. Lucky, man, I move the camera. I go and press 3Z. It will hit the camera just now. Oh, man. This is very dangerous, guys. Don't do like what I do. 110.22. Very, very dangerous, guys. Okay, so we have to do everything back again. Careful that you don't press the Z coordinates wrongly. The problem is because this is linear sling, so the Z moves up and down. If you are using on a fixed gantry, the bed doesn't affect. I mean, if you put the you don't need to do anything with the Z, because once you touch it, you move back only in X, Y. But this one you have to bring down the Z, so you have to be careful of that. Okay, let's pick up 2T0 back. Okay, let's bring 3038. Make sure we key in 38. Let's try 110 here. Okay. Okay, Y is 122.6. Nope, 122.56. 54. Okay. X is 109.84. 86. 88. Okay. 109.88, 122.54. So we change here back. 109.88, 122.54. Z is at 38. Okay, correct. 109.88, 122.54. Okay. Let's draw off again. Let's Z38 109.88. Okay, good. Okay, now we pick up T1. Let's move Z38 109.88. Okay, now we shift the camera again. .32, 0.36. Okay. So 111.36. Y 122.94. Alright. So let's drop T1 and pick up T1 again, just to confirm. $38 111.36. All right. Woohoo. Okay, now next step, record XY position. Okay, already record. Repeat for all the remaining two. So now we were going to be doing T2. So let's go to T2 first. Pick up T2. We go Z38. Let's follow the Y T0 coordinate for X. 109.88. 122.54. Okay, so there is the nozzle. Alright. Wow, this the X no change, 109.88 also. And the Y is 123.54. Okay, let's try again. Drop off T2, pick up T2. Pick up tool number 2. Okay, let's go down to Z38. What's the coordinate just now? 109.88. Alright. Okay. Once you finish, use the copy button in the calculated offset section to paste into your config file. Okay, so now you will get the offset already. The next step is save, restart clipper, close mata, proceed with entire Z calibration. Okay. So we get the offset here. So X 1.48. I don't know what's this. Let me try this. Copy T1. And then just now what did it say? Copy T1. So let's open up our files here. Tool 1 offset. Is it copy paste? Oh, you will come out like that. Okay. So wait. What? Okay, so let's try to here. Is it like this? Variable X offset, variable Y offset, Z offset. Variable underscore X offset, Y offset. Yeah, correct. Yes. Okay, so we can save this. Try, Z we don't do first. Okay, now we copy for T2, tool number 2. This is the variable offsets here. So this is T2 offset. Y is 1, X is 0, Y is 1, correct. For T1 just now, X is 1.48, Y is 0.4, correct. Okay. So we already saved this, guys. Okay, so once this has settled, we can close this already. Then we will open up this. Okay, now I can change back. No need my screen. That's my screen. Okay. So this one we save. Let's close first. Now we got the offset for the camera. We can remove the camera because next we're going to do is the Z. So we need to restart everything first. Now, you know why we do it this way? Wait, let me remove the camera. Because sometimes your nozzle your nozzle might not be aligned properly between all the tools, right? Some of your nozzles, some of your nozzles might be further in X or Y and Z. So why we set the nozzle offset for the X and Y first, so that all the nozzles are perfectly centered when you are probing the Z probe. So that's the reason we normally do XY calibration first, because since this camera only do XY. If you are using like sex ball or tabi or notch, you can do everything all at once. But for this camera, why I like to use camera is because it's more accurate, because you are measuring by the nozzle orifice instead of the edge of the nozzle. Because when we are using cheap nozzle, sometimes the hole might not be exactly at the center of the nozzle. Okay, we can keep this cable first, because next we are going to need the cable to connect the intie to the MCU. Okay, we put this cable on one side first. So here we can save and restart first. So let's save and restart. Save and restart. Okay. So now what we're going to do, we're going to need to find a end stop to put this intie. Let me check. Hold on, let me check what port SKR ini. Pin. I think we can use the extruder and stop. Extruder and stop, first and second down here. First and second is extruder and stop. On the right is the 5 volt. Okay, let's try to put the extruder and stop. Let's off the printer first. Where is the extruder and stop? Hold on, let me check again. Where is the extruder and stop? Extruder and stop. So 10 PS power and stop. Okay. PS power and stop here. This should be this 10 PS power and stop this. Let me get a light. Okay. So let's connect this. Let's on the printer, guys. So we're going to use PC15. The pin is PC15. So BTC tabi Z, yeah. So this is for Z only. Oh, okay. It's not connected yet. So I just restarted the printer. Is it connected? Oh, wrong tool. Wrong tool on the case. I forget to change back to T0 just now. Let's do a firmware restart. Okay. When you do a firmware restart, if you look at the screen here, hold on. Always make sure that this T0 has light up and all the checks are finished. So this means all the checks are finished. Let me show you what I mean. Okay, I do a firmware restart. Make sure you let it run, do its check, initial check, and the T0 button is light up. If you have T0 on the tool, on the carriage. So you see here, okay, let it finish. Once the tool T0 is ready, okay, that means you know it's ready. So now what we do is let us test our button. Oh, we need to change the button. So BTC Tabizi button is PC15. PC15. So let's save and restart. We need to test the button. Let me open up the command. What's the command? Tabi sensor pin. Let me double confirm again. Tabi sensor pin, correct. Okay. So we put the command query, query the command here. What's this? Not valid for button. Oh yeah, because we haven't had include. We have to include BTC Tabizi. Hold on. BTC, oh don't have. So BTC underscore Tabi underscore Z. Let's use this. BTC underscore Tabi underscore Z. Okay, let's try. Let's try again. We double confirm the Tabi button here to make sure that the Tabi is working. Let's try again. Release. Now I press and then we test the command again. Press, I release. It's released. I press. It's pressed. Okay, the Tabi button is working. Now it's released, right? Yeah, okay, correct. So Tabi is working. What we do now is we will home all the printer. After we home all, let's do a quick because I'm still a bit worried about the tool change. So let's do just a quick one iteration of bash macros of tool change. See, that's a problem. Okay, let's do a motor off. The reason is because not heater, sorry. The reason is because just now when I tilt my printer, I think the dock slide move slightly. So we move back here. Let's do a firmware restart again. Just now when I tilt my printer, I think the docks is not aligned properly. Okay, we will home all. If this one fail also, I think it could be the nozzle offset, because this sling mode for BTC, it seems that the nozzle offset is not set properly. Let me try again. To change, I want only one. Okay, everything is good. So as usual, let's bring our Z up 33. Let's put this entire here. Let me hold on. Change the screen so that you guys can see. Okay. We will move the nozzle as close first as possible to the Z probe. Let's move it down. Okay. This looks like good. What about here? Let's move the good here. Good. Okay. Let's move the Z down some more. Okay, now the Z is almost at the top of the Z probe. So what we do now is we're gonna lift the Z up 5 mm. So we put the Z up 5 mm. Now it's 26, so we need to move it to 31. Okay, 6 better to be safe. 6. I don't know I will get a timeout or not. I don't know whether I will get a timeout or not for this. The timer too close. We're gonna try. But I think previously I didn't get a timer too close. We see about here now, okay? So what we need to do for Tabi Z, let's open up here. Hold on. And we're going to hit this macro. Let's see, where's the macro? This Tabi Fine Tool Offset. So this will do the Z offset for all the tools. Okay, I will do it on my handphone because I'm closer with my handphone. All right, and I want to change this to zoom so you guys can see. I don't know how much closer can it get. Hold on. Let me just try to get this thing closer. Oh, cannot really. As close as possible. Am I lah? I just hit this. Hey Yoku, how are you, man? I just did the XY nozzle using Mata that you created. Works very, very well. So now I'm going to do the Tabi Z. We're going to see how it goes. If everything goes well, hopefully. Okay, Tabi Fine Tool Offset. Let's go. Okay, I think when you do this, it will heat up to 150. So actually just now we should do a PID tuning first. We didn't do a PID tuning. So when you want to do a Tabi Z, it heat up the nozzle to 150. So just now we should have done a PID tuning first better. So that now it's doing the first tool. We see whether there's any timer too close or not. Always stand by your hand at the emergency button in case anything goes wrong. Okay. Now it's doing this probing for the second tool. One thing about this kind of nozzle calibration is, of course, very slow compared to using, you know, plugin script, right? But at least one thing why we prefer to use macros instead of scripts is because if there's any update to Clipper, there's less tendency for BTC to fail, to crash. So it's much more easier to use macros instead of a plugin or any script outside of Clipper. Okay, now let's see, it's doing this now for the third tool. Okay, so it's done. Yeah, man, it's working very, very good. Thank you very much, Yoku. I'm going to be uploading the Chrome script to GitHub so that the others can use that as well. Okay, now let me open up the screen. As you can see here, I turn off my camera. Hold on. As you can see here, it has give out the result already, right? Okay, first let's pick up our tool 0 first. We can remove this already. We don't need this Tabizi anymore. You can put one side. Okay. Just now, let's go to the console. Where do we start? We will start doing the calibration. Is it here? What is this? End tool offset calibration. I think because I use my phone. Yeah, because I use my phone, so it's not inside here. Okay, but what we need to see is just, we see from the top. Right? So, just now, this is for tool number 2. Tool 2 at Carish. The Z tool offset is Z minus 0.45. So tool 2, Z is minus 0.45. Minus 0.45. So I can delete one line. Okay. So this is for tool 2. Now let's check the console again. So this one just now is tool 2. Now we need to find the tool 1. Okay, this is for tool 1. Tool 1 at Carish. So tool offset for tool 1 is minus 0.80. Minus 0.80. So tool 1Z is minus 0.80. So we can save and restart now. Okay, guys. Looks like it was a success. Okay, after the restart, we can pluck out the intie. We don't need intie anymore. Let me turn off the printer first. So let's remove intie. We don't need that anymore. This is a success. So this intie calibration is a success, and the tool itself is a success. Okay, let's put it one side so that we don't destroy this. Okay, let's turn on the computer again. We will do a PID calibration next. Then maybe we can try to print. I have filament to test print. Let me try to put the filament here first. Hold on, huh? Right. So the filament is here. Okay. So let's home all first. Oh wait, just now as usual, we already move. So let's move the. The pen. Oh, this thing is here. Okay. So home all. Okay, Yoku. I will upload it in GitHub also. Thank you for that. Thank you for taking your time and your effort to create it. The script it is very nice, very useful. Hopefully in the future, like you mentioned, we can straight away copy the config directly into Clipper. So into BTC. So it's much easier. Okay. So let's do a PID. Let's open up. What's the PID? What's the command? Calibrate PID. PID calibrate heater extruder. Okay. So let's do the PID. PID calibrate heater. Heater equal extruder. Target at 200. Okay, send. Okay, the fan is turning on. Very good. This hot end that time when I turn on the printer, but I didn't set the pin, the hot end was heating up. I don't know to what temperature, and it was smoking. Very, very hot smoking. So always remember to set your pin properly first before you turn on your printer. Hopefully the hot end is working. If not, we cannot get a print. It goes to 224, so high. Overshoot. Yeah, okay. That one I think I will try it. I will try see whether that if I change the offsets, is it possible to just save or not? Because now I just want to get this thing printing. So the next time offline, maybe I will do the test. Hopefully, once it's working very well, and then it's the best already. It's perfect already. The other thing more better is if it could also save the Z temporarily and save the XY offset temporarily so that you can straight away do the tabi Z only. That is the best actually. So that we don't need to off and then on back again, plug in again. Now it's doing a PID for tool 0 first. Then we do PID for tool 2, tool 1, and then tool 2. And then we will do PID for the bed. And that's it. We can try a print. I think I'm going to, if everything is working already, before I do the 4 tools, what I want to do is I want to reprint my back plate and also the cowl, because this one is for the from the first batch that I haven't made any adjustment to the micro switch and also to the DuPont. This is only have 5-pin DuPont. So I'm going to reprint and then I'm going to put in the new updated one, because this is for the old the first print. Has it finished or not? Haven't nah? This hot end is the Triangle Lab CHC Pro hot end, ceramic heater. I think how many watts? 30 watt, 60 watt. Okay, we already got the. So remember that this you don't save the config and restart. You need to save the config to the tool itself. So KP is 15.186 for tool 0. Tool 0, where's the PID? Oh, extruder section. Okay. Let's save it. KI is 0.739. Let's save it. KD is 78.018. Okay, we got to save this. So next what we do is we just change to T1 and then we do the PID for T1 now. Error again. Let's just do a firmware restart first for this. Maybe because of the heating. Is it affected because of the heating? Let me check the. Okay. Let's home all first. It's not really stable yet. I think there's a problem with these motors. This motor is not strong. It needs stronger motor. Hopefully Jason can sponsor 2 more stepper motors. If not, I will just take from my EasyBoard dog slide motor. Okay, let's change to T1. Okay, let's move the Z to, just move to 50. And we will do the PID for extruder 1. So now is extruder 1. And we will do the PID. Okay, now we are doing calibration for extruder 1. This is TZ V6 3.0 hot end. I really don't like TZ hot end because previously I have 2 of TZ hot end, but they are the version 1 or version 2, I can't remember. And it's really problematic regarding the temperature wise. So I'm just crossing my fingers on this hot end. Hopefully this doesn't let me down. And if you see at how he do the PID so fast, go up, go down, go up. I'm not very sure whether this is accurate or not. Okay, PID is complete. KP is 34.433. This is for tool 1. KI is 16.397. KD is 18.077. Okay, we save it. Now let's change to T2. See whether it can change to T2. Let's bring the Z down 50. And then let's do the PID for extruder 2. So now it's extruder 2. You can see here also extruder 2. So you put extruder 2. Let's do the PID for extruder 2. Okay. I'm just hoping everything goes well. We can try to do a test sprint. Fingers crossed. Okay. So fast. Unbelievable. Unbelievably fast. KP 34.587. That's the Fenton's one. 4.587. KI is 16.471. KD is 18.158. Why is the KI 16 only? Just now, KI is, 16. Okay, correct. Okay, now let's change back to T0. Okay, now we can do PID calibration for the bed. So it's this one. Bed Haiti 60. Okay, let's try. Okay, the bed is sitting up. This is very slow bed. After using VisiBot and Warren 2.4, using AC bed, now using DC bed, the temperature goes very, very slow. Let's bring down to 50. Oh yeah, we cannot move yet because we are doing the PID. Very, very slow. It's a bit hot. Not so hot. What's the temperature now? 50, I mean. Yeah. So we just need to wait. The new Intai probe. Very, very easy, guys. And thanks to Yoku also. Yoku, thanks for recommending the design as well, this model, so that we can get to do something like this. Very, very easy. Very simple. The dowel that I have is rounded, so I have to file it to make it flat. You have to make the top here flat as possible for better reading. Don't go for those rounded dowel. What's the temperature now? Let's check. Yeah, can feel the hot. After this, we clean up the bed a bit. Or later. Now it's heating up. Later not. After this, then we will clean the bed. Clean the bed a bit, and then we load the filament. Then we can try to do a first test print. Should we use all the 3 filaments or not? I think yeah, easier. We just do all the 3 filaments. Much more easier. Sorry, yeah, very slow this one. But that's the thing about this Ender 3. Without this printer, I wouldn't go as far as where I am now. This printer has served me very, very well in my learning steps. There's a lot of modification that I do, a lot of things that I do with this printer. This is considered a treasure. This printer can be inside the National Museum. But now, you see, he has become a tool changer. Woo! PID, this one clipper we can close. Oh yeah, I think later we will do, before we do any printing, let's try to check the input shaper also. Yeah. We will try input shaper also. Hi Khalil. Yoku, this Khalil is 3MMO. He also is doing the Linux Sling also. PID parameter of each hot end in printer.cfg. That is, this way you can use save config to store the number. Yeah, but the tool has its own section as well, extruder section. So the PID is better that it's kept together with the tool section. So if in any case that you change also the tool head, you know that the extruder section need to change as well. That's why we keep anything pertaining to the tool head to its tool section itself, rather than saving it to the printer.cfg. Because sometimes you might forget that you ever did the printer CFG there, the PID there. Sometimes you might forget when you do any tool, you change the tool head. So it's better. Yes, correct. Yeah, I know that you can save it inside printer.cfg. But like I mentioned, it's better that you keep every section of each individual tool head inside their tool config itself. So that in the future, anything that you do, you know that you need to do the PID. There's no PID. If not, if let's say you forget, you change to another hot end or you change to another tool head, you change anything to that tool head, you just carry on printing, it will read that PID from your printer.cfg. So the PID is different in it. So it's better that it's inside the tool config itself. When you change, you know that everything needs to change. Okay, they haven't finished yet. So slow. How many rounds is it? 1, 2, 3. It's only 3. Hey, Austin. Hey, Austin. Thank you for joining in, Austin. When are you going to convert your Cyber Boom, sorry. When are you going to convert your Cyber Boom into this? Let's make this happen on your Cyber Boom. I'm just waiting for you. Wait, let me check how long more. I think one more time. Yeah, one more round, I think. 5 rounds total. Once it go 5 rounds, we will do that. Thanks for joining, man. Hold on, let me open up my PMD. Okay. Yeah. It's still not finished. I saw that you have a problem with the motor mount, is it? The motor mount was breaking. Okay, let me see. Is it finished? Not yet. One more time and it will be finished. Yeah. I wanted to watch your stream as well, Austin. I saw you post a lot of live streaming video, but it's in Twitch. So I don't have a Twitch account, but I'm trying to register one Twitch account so that I can watch your stream as well. Okay. I think it should be finishing after this. This is the last one. Open up the screen here. I'm curious how the input shaper is going to be. I think one of the tool head, I think tool number 2, I have to put some washer between the cap nuts because the magnet is too strong. Somehow this tool number 2 is too close to the carriage. So I just put a washer and it fix it. Okay. Is it going to finish? Yes. All right. We got the results. KP67. Oh, this one we can save and restart. Yeah. For the bit, we can save, config, and restart. No problem. So we will save, config. Oh, no. We don't want all this. Oh, man. We don't want extruder 1 and extruder 2. Let me see my printer.cfg. Do I have any save below? Ah, yes, heater bed. Okay. So I can put it here. 67.154. Save. And KI is 1.571. Save. And the KD is 717.71. Okay, we're going to save and restart here. Okay, we're done PID for tool 0, PID for tool 1, PID for tool 2. We have done that. We have done the nozzle offset calibration. We have done the PID for the bed. Now we're going to do input shaper. Let's try input shaper. Let's home all first. Ah, I see. Okay, I got you, Austin. Yeah, I will try. I think I'm creating a Twitch account so that I can watch it. Hope to join you in stream soon. Okay. I think I don't know whether I have clipper resonance testing, resonance compensation. Clipper resonance compensation. Where is it? Measuring resonance. Yeah, here. Let's see whether we can do it now. Numpy. I think we have the numpy already. I just need the command. Oh, I think we can just do it from here, right? Calibration and test. Test resonant X. Okay, hold on. Let me close this. Okay. Calibration and test resonant X. Let's see whether it works. Okay. Okay, it's doing input shaper for tool 0. This is X first. Don't know what's the speed's gonna be. Hopefully is above 3,000-4,000 onwards is considered excuse me. 4,000 speed or above is considered okay. Maybe 5,000, 4,000, 5,000. If 3,000 to me is still slow, there's something that's need to be improved. But 4,000 and above considered okay. And then the belt also, I don't know whether I tuned the belt properly or not. Not very sure. Let's just hope everything goes well. And then, you know, with this dock slide, everything might be shaking. So we don't know how it is. We're gonna see it. All right. See you, Austin. What's the clipper command or this? This is to get the, this will get the graph, right? So I will need to get the graph. Okay. Oh, heaven. Why is it like stuck? Is it finished already or not? Oh, wait for calculation. Okay, okay. It's like a bit slow. Is it regarding my pi? This pi maybe too slow. Where's the result? Why the result is not coming out? Let me close everything first. Why is the result not coming out so slow? Is there a problem? Why are you waiting for calculation? It's so slow to calculate, is it? Come on, man. What are you waiting for? Let me put all the filament so that at least it has the filament. What's this PLA? So it's measuring with the filament also. This way it's more accurate. Okay. And then we put another filament. What filament are we going to use? What, we got blue, white, and black. This is PLA, is it? What's this? PLA. Okay. Going to use this. Alright. Okay, resonance data return so slow. Okay, now let's do the Test resonant Y. But I don't have Y, right? Timer too close or overloaded. I don't have Y resonance because the toolboard is the one. So no point if I do a Y resonance. Just need to do the X. Hold on. Okay. Timer too close. I get timer too close just now. And it was reading 2000 only at the speed. No good, no good. 2000 is too slow, guys. The one that. Let me download first the calibration. Hold on. P0. See the graph. Noisy, a bit noisy. Okay, never mind. We just do for T1 next. Just now what happened? Oh, already restart already. From where restart? Yeah. Okay, so we have to home all back. After this, we will do the resonance for T1. 2000 speed only, not good. That means I need to change something. I will post the graph in the Discord tomorrow. 2000 only. Let's change to T1. Let's move down to 30. And let's do the test resonant X. Now let's try T1. Out of these three, we will see which has the best, and then we see what's the difference. Maybe the dome nut, the cap nuts, or maybe the umbilical. We will see what's the difference between all three so that we can know. Maybe my belt also. My belt is like a bit sengit. But no problem. After this, we will just do it. So I'm just to get a rough idea of the input shaper. Alright. After this, we will load filament and we try to make our first print. Still got time. Just to test. That means this pi is not very good. I need to change two things. I need to change the MCU to something that's scan capable MCU. That's number one. Number two is I will try to change the pi. Something with more USB port so that I can use. For the meantime, it's good enough already. Okay, let's see. Okay, it's finished. See the frequency, the processing is so slow. You need a lot. Creeper shutdown now. You haven't processed, timer to close already. Overheating. Oh yeah, one of the reason it could be overheating. I don't have a fan there. I should put a fan there. Wait, let me remove this tab busy first. So we don't need already. Can save and restart. I don't have a fan at the MCU, so that could be the cause also. The fan at the Pi. I need to put a fan there so that the Pi is cool. But let's try to load filament and try to do a print. You see how Let me see whether is there anything that speeds up from here. Yeah, I don't have. So it doesn't even have the calculation. Yeah, never mind. T1. Okay, let's home. Hold on. From where we start? Let's just home. Home on. Let's bring the Z higher so that we can wipe the bed a bit. Oh, very dirty. Bed is very dirty, man. Okay. Now let's load the filament. We load the blue filament first, yeah. Just to test, just to test the print. Hold on, Where is this? Why does the filament don't want to go inside here? Is the hole too small for this? Okay, I think the hole is too small for this. What we do is we turn off the printer first. I need to drill this hole a bit bigger. Hold on, very fast only, guys. This part. Let me check. Okay, so what we're doing now is we're going to remove this umbilical adapter because it seems like the hole is too small. I think I already edit the hole to be 3 mm. Let me double check again. This one is only 2 mm. So 3 mm is much better. Yeah, 2 mm. So I got a drill here. Okay. So we're going to make it 3 mm. So that the filament go in much better. Why does this cable doesn't want to go in? Wrong. Okay. Okay. Let me check the others. Yeah, this one already 3 mm. What about this? Yeah, this is also 3 mm. Okay. Let's turn back on the printer. This time we can load the filament already. Sorry guys for all the hiccups during this stream. As usual, it's the first we're going to test. Let me set up Orca so that you can see what we're going to print. By the way, Orca has released the new Alpha 2.4.0 Alpha. So that I think the one that I'm using now is Def 2.4.0 Def. So if you use the Alpha, you can fix the extruder when you want to add extruder. Okay, hold on. Let me see under image zoom. We're going to add a window capture. Yes. Okay, for screen, window capture, okay. Okay. Okay, let's home all. And also tool number 2 don't have a nozzle brush. Because I got no spare nozzle brush already. I think I need to buy. And I'm not going to buy the Bamboo Lab. We are not using any more Bamboo Lab stuff. We don't support Bamboo Lab in any way. So there's no more Bamboo Lab stuff, Bamboo Lab nozzle wiper. We're going to use either Creality nozzle wiper, the silicone wiper, or we're going to use Flashforge or Snapmaker. We see what is available. We're not going to use any more from them really. Okay, let's move Z50. Okay, let me try to fit in the filament. Okay, so this is PLA. We hit up to 200. So we will hit up to 200. Oh, sorry. Once we reach 200, we will try to extrude some plastic and we see how it goes. Okay, 200, extrude 100, extrude. Is it extruding? Yes. I don't know whether you guys can see that. Let me see. Let's extrude some more. 50. Yes, it's extruding plastic. Right. But why is the extrusion like that? Like not very nice like that. Is everything tight? Let me check this side. Is it tight? Okay. Let's try to extrude again. It's bubbling. Could be wet, the filament. But at least it's extruding plastic. No worries. So let's turn the heater off. Now let's change to tool number. Let's change to tool number 1 and then we load the plastic in tool 1. Oh, we never home just now. I think we didn't home. Okay, let's bring tool 1 down. Let's heat up to 200. We're going to load the second spool. This one also, I think, wet filament. These are all old filaments. Okay. Is it pulling? It's not pulling. Okay. Alright. This one much better than the first tool just now. The first tool, the extrusion like problem. Maybe the nozzle is blocked or what. I'm not very sure. Maybe I will change the hot end next time. Okay, let's turn this heater off. And Let's change to tool 2. And then we see whether we can get. Let's hit tool 2 to 200. And then we load this filament. Why is this not going in? I didn't put the PTFE properly or what? Let me try to remove this PTFE here. It's not loading in. Like something is stuck. Maybe the PTFE, the PC4 connector is not properly. Okay. So it's this way. Okay. Alright. I need to adjust the PC4 connector also. So let's load this toolhead. This is a proto extruder. I don't know whether is the direction correct or not. Yes. Yeah, this is correct. It's not pulling the filament. Okay. Let's try again. 100. Okay. What's the gearing ratio for photo extruder? I think this gearing could be wrong. Tool 2, proto extruder, gear ratio and micro step. I think, wait, if I'm not wrong, jet beam uses proto extruder. Let me check from the clipper here. Clipper, tool 0, proto extruder, yeah. 50, 10, 22.68, 16. Correct? 50, 10, 20.16, 200 rotation. Oh, correct. Okay. The black also is a wet filament. Yeah, the black also wet filament. But never mind lah, just for test. Okay, we turn the heater off. So all 3 tool head filament are loaded. Okay, all 3 tool head filament are loaded. Okay, now we will go to Oka slicer. Let me open up a screen here and Oka. Okay, we will need to set first. So this is Linux under wire. Okay, correct. Everything is correct, yeah. Okay, so generic PLA. This is what? Elegoo, Sunlu, Elegoo. Okay, let's choose Elegoo PLA. This is Sunlu PLA Plus, yeah. And then the third one is Elegoo PLA also. Okay, the first one is blue, yellow, black. So we put blue, yellow, black. All right. So let's set the machine. What is the machine size? The machine size is X220, Y250, X220, Y250. But this is only a 235 bit, right? Yeah, 235 by 235, correct. So 220 by 235. What's the Z? Z is 213. So we put 210. So 220 by 235. Okay. Z is 210. Okay. All this, I think we don't need to change first. Just want to test print. Don't know whether all is correct. G-Hawk height 0.4. Yeah, can also. This one all later, then we can change. Just to test to print. Okay. This one all from previous setting. What's this print start? Is all this print start correct? We need to take the print start from our print start. Just follow from previous print start. Let's open up my config. Hold on, Linux tool changer. Not from here. Sorry. We need to take from Linux Hive initial push. Okay, we want the initial push. Machine G code there. Print start here. Print start. Save. Print start. This. Okay. No need to set, everything should be correct. Because it will print in the front. Okay. Print N will be print N, nothing else. Before layer change, all no need. Okay, pause. Okay. So let's save this. Okay, print start, we done already. Machine start decode. Print start, okay. Now we can close this. Does our device have print start? Hold on, Start stop, yeah. So print start, correct. This is what I use. Okay, this one also we need to change, status homing. We can what is GX at YX, then home Z, home YX, then home Z. This one no need, we just change G28, it can home all already, right? Yeah. This one we can just change to G28. Bait mesh calibrate adaptive one. This one I also don't know. We try. key current tool, move tool head to the front left, and then status hitting, extruder temp, status busy, and then printing. Okay, I think should be correct. We don't have any detail or QGL, right? Yeah, don't have. Okay. Then for print end, set. Finish T0, then max X divided by 2, center back. Okay, center back, Y not 200, Y is 230. Okay. Then we can save and restart this. Okay, we got our print start, we got our print end. Now let's load the model. We're going to use the test print. Normally what we test print. The first layer test print. Linear Z offset first layer. Okay. Yes. Okay, this is it, guys. So let's change them. 2, 3. Then this one will be 2. This one 1. So up here I put let's put the here yellow, here black, here blue. Then here yellow. No, cannot. Blue, black. And here yellow. Okay. This will be our test print, 1 layer. Why is the what's this? Okay. Global. I also don't know why you need to print this prime tower. I haven't changed anything here. 0.2 PLA Boron speed. Okay. Prime tower enable. I think don't need prime tower first. Yeah, correct. Don't need prime tower first. Minus 60, 50 second preheat. Just leave it like that because this is from previous one also, I think. Okay, guys, we just try to test print this. We see how it goes, yeah. Let's slice it up. We got Z hop on all the extruder, right? Z hop, correct. Okay. We will test print this to check the first print test. We see how. Let's upload this first. We start the printer. Always like to lose communication, this printer. So I'm thinking of because of the pi is hot. What's the pi temperature? 45 degrees. Okay. Okay, now we will test print. Okay, guys, remember that whenever we test print, I think this was previous model that I print. Okay, whenever we test print, always stand by your hand at the emergency button. Alright. Okay, let's try. Hopefully everything goes well. Bismillah. Did I set the bit? I think I set already. Did I set the bit? Printing time and bit time. Printing at 220, bit at 55. Can. Okay, guys, it's printing. We see how. Let me turn it up this way. Okay, let me turn off the Chrome. See how it is. And we check the first layer as well. So from the phone, I'm going to do any Z baby stepping. See whether the Z is nice or not for first layer. I don't know how everything will do. I haven't checked properly. I just want to see it printing. Always stand by your hand at the emergency button. Remember, if anything goes wrong. Hopefully everything goes well. The first sprint. This first sprint we will do, and then we will call it a day, guys. I will do another print next stream, maybe. Okay. Probe triggered prior to movement. Because of the adaptive. Oh, you never pick up the probe to do the adaptive. Okay, so that means that's a problem because it had the print start. So the print start, just now you already dropped the probe, and then it want to do the bed mesh calibrate adaptive 1 margin 1 left. What's this? So from G28 just now. There must be something. Okay, let me see my previous config. What did I put there for the start stop? Bed mesh G28Y X G28Z, then bed mesh calibrate adaptive 1. Okay, let's try to follow it. Start stop. This. Okay, let's see now. If still cannot, that means we don't do the adaptive bed mesh. Just ignore it. Okay, let's try again, guys. We see how this time. Just now when he pick up the probe and then he drop the probe, after he do the Z, he drop the probe. After that, he cannot do the adaptive bed mesh because the probe is not attached. So that means we have to attach probe first. Attach probe lock. So we attach the probe and then it do the adaptive and then drop the probe. Okay, I think we need to add some commands. Fingers crossed. This part. So now he want to do adaptive, he cannot do adaptive already because got no probe. Okay. So that means I think we have to do the attach probe lock. Let me check the clicky variables. Wait, let me check the other config of my Hive VisiBoard. Yeah. Okay, so it's here G28 attach probe lock. Okay, guys, it's this one. We need to put this here. Okay. So not this. We go back to our start stop. We need to put this here. So G28XY, sorry, not XY, G28YX, YX. And then attach probe lock, and then G28Z, and then it will do the bit mesh. Okay, let's save and restart. Okay, hopefully now it will work. Fail automated reset of toolboard 2 pula. Okay, let's try to print. Standby hands on the emergency exit. Hopefully this time we get to print it. Come on. This one, it will do adaptive, I think, yeah. What's the temperature? 53, okay. Okay, will you do adaptive now? Yes. Okay, it's doing adaptive bait mesh, correct? Fingers crossed, fingers crossed. Excuse me. After this, it will drop the probe, move to the front, hit up the hot end. Let's see whether it does correctly. Why you go and change and never drop the probe? Let me take out the probe, man. You never drop the probe. So the bait mesh script we have to change also. Bait mesh, I never change the bait mesh. Okay, now it's doing the... Why is it doing the line this way? Now hitting up tool 0. After that, it will change. Oh, just now was the first prime line. Okay. The first prime line actually no need already. Yeah, okay. So we can take that into, we can remember that we can do now. Now it's doing till 2. Yes. Okay, now you will print this. So this is the first tool. It's a bit too high, I think. For first tool, we can adjust the Z. Let me see when it printing. Too high, so put it lower a bit. Lower some more. 0.15 now. Some more. Or is it the other way around? No, correct. -3. -4. -5.5. It knocked over the pin already. -6. Too low. -5.5. Okay, for tool 1 we got it at -5. Okay, I already screenshot, so we know tool 1 is at -5. This is too near. Okay, let's bring it up. .5 is too near. First layer 2.5 is too near. Okay. 3. .5. Okay, 4.5. T0 is 4.5. This one looks a bit better. Can bring it closer some more. Okay, yeah. Yes, okay. Now we got the offset also. Okay. We managed to finish the print. Woo! But we need to drop off the dot for the back mesh. Okay, let me check. Blue. Okay, yellow. This ender bed very old already. Okay, let's see what we have just now when we screenshot. This is tool 2, tool 0. Tool 0 we need to is too close by 0.45. So the probe offset tak sangat kecil kan. We need to lower by 0.45. Probe lower by 0.45. Probe lower by 0.45. So that means 5.562 minus 0.45. 5.112. 5.112. Okay, 0.45. Now for tool 1, just now, what do we have for tool 1? It's too far by 0.5. Too far by 0.5. So just now was 0.45. Really lower. So 0.05. So we need to lower it by 0.05. So minus 0.85. Okay, for tool 2, we need to minus by 0.1. So that means for tool 2, we need to lower by 0.1. So 0.45 minus 0.1. We need to increase by 0.35. Increase by 0.35. Increase by 0.35. That means here minus 0.1 only. Save. Okay, now for this bed mesh. The printer, right? Bed mesh. Oh no, this one no. Bed mesh is under clicky macros. Dock, probe, unlock. Dock, probe, unlock. So we need to put this dock, probe, unlock after the start stop just now. After the bed mesh, we need to drop this. Okay, and then we need to remove this first line here. This status busy, status printing, or we don't have the LED first, so never mind. Okay, now let's try it again one more time, just to see the first layer how everything is. Because just now when we're doing the calibration, everything is not with the bed heated up, so there might be changes because of the bed. So we're going to try again, guys. Last time, then we call it a day. Okay, print. It's alive. Yes, yes, it's alive and printing. I just adjust the Z calibration because just now when we do the nozzle offset calibration, everything, we didn't hit the bed, hit the extruder. This we need a nozzle wiper for tool 2. Another CG, who are you in Discord? What's your name in Discord? I didn't know that. So now we're going to do another test print again after some adjustment with the Z. You see how it goes, yeah? Once we do this test print, we can call it a day. Yeah? Call it a day. We'll continue again maybe the next stream or offline. I think I want to, what did I want to change just now offline? Did I want to change anything? Can't remember what I want to change. Never mind. We can see how everything is. Stand by on the emergency stop in case. Okay, now it's going to do the adaptive bed mesh. After you do the adaptive mesh, just now it didn't drop the probe, so now it should drop the probe, and then it doesn't do that prime line first. Okay, we see how it goes. Just want to see the first layer only, that's it. But at least it's printing, it's alive. Yes, it's printing. Okay, let me zoom in so that you guys can see. Let me remove this. Yes, okay, now it draw off the probe. Good. Now it will move. Oh, it will change. Okay. So this, it will do the prime line. Waiting for all the tools to heat up. Huh? Why he go and pick up that one and then he never do the prime line? I also don't know. Give it some light. See, you guys can see, if I give it some light. Okay, this is too close. We got a problem with tool number 2 is too close. Okay. We got a problem with tool number 2 just now. It was scratching the bed. It's too close. Let's do the cancel first. Cancel. Okay. Sorry. If I did the motor off, right? If I did the motor off, heaven. Okay. Sorry. Okay, just now this tool is too close. Tool number 2 is too close. What's the previous tool number 2 Z offset? 0.45. So we should leave it at 0.45. What's tool number 1? Minus 0.8. Okay, never mind. We just leave them like that first. We see how everything is. Okay, let's do a test print last and then we call it a day. It's like too excited to not do it. Let's do it. Okay, the pause macro also, we need to change the pause macro. Just now the pause macro, it was moving while the dock slide is. We haven't changed the pause macro, so we need to change the pause macro. If this still cannot, then we call it a day. I will do the Z offset offline. You know, it scratched my bed. There's a bit of filament at the hot end. Okay. So I don't know why he go and pick up. Oh, stuck again. Why is it stuck now? Is it losing power or what? See, all the sensor switch is correct. Okay. Let's do from where we start first. The motor hot. Not so hot. Bit rough, eh? There's a bit. I think there's a bit of a problem with the stepper motor. What seems to be the problem? Everything seems to be okay. Let's try again, guys. No need from where we start. We can just home all from here. I think the stepper motor losing power already.
Memperkenalkan video musik, cara baru untuk menikmati premium. Masukkan video klasik ke antrian atau ikuti terus video terbaru dari artis-artis papan atas. Cobalah dengan
I hear something. Looks hearing like something down here.
untuk mempelajari lebih lanjut.
Okay, let's just try to print. Waste time.
Jam sibuk, kemacetan sangat kacau. Tapi musik Anda jangan sampai kacau. Lewati iklan dan biarkan lagu tetap berlanjut. Coba sekarang dengan Spotify Premium. Dapatkan 3 bulan sehari.
So that means what I need to do, what I need to change is maybe I change a different stepper, a stronger stepper. Maybe I change to that dog slide stepper, the dog slide on the VisiBoard. On that VisiBoard dog slide, the motors, maybe I can change the motors here. That's number one. And then this motor can be used for this LDO slim stepper. Just to see whether if more power is more stable. Because right now these are very weak. Okay. What happened? Something wrong again. That's why I think the Y is not homing properly. Because of not enough power. Let me feel the Y stepper. Oh, the Y stepper is hot. Why all this problem happening? Let's just try to print and see how. Last time, guys. Last time. Let's try it for the last time. Then we call it a day. I need to change the motors. The motors not strong. This motor very long, very old. So we're going to change these motors. That's number one. Maybe I take from the dog slide motor. That's much bigger. The LDO motor. Try one last time, guys. After that, we call it a day. This filament at the nozzle. And then also, I think I need to add a feed down here in front. Safer to add a feed down here. Okay, we stand by, hands at the emergency button always. I don't know why he go and change to this tool first. If it's not going to prime this tool, why he change to this tool, tool number one? Must be something. What's the temperature? Okay, we're waiting for the temperature to reach 220. Oh, you see? Just now when you want to go out already, he like skipping step, no power. Okay, so that means the motor, I need to change the motor, guys. So we call it a day from here. I need to change this motor. This motor not strong. Number one, maybe because of its running and then everything below is hot. So that's number one. Oh yeah, I need to put fan. Okay, so what I will do now is, oh my god, filament. Okay, so we were just now we managed to pin just the first layer a bit. Then after that, now it's haywire because it's losing power already. So my guess is, number one, this motor is not strong. These are cheap motors, very very cheap. Maybe $5 this motor. That's number one. So what we're going to do, I'm going to take the motor from the dock slide of VisiBoard, the LDO motors. So I'm going to replace them here for both. That's number one. And then number two, I'm going to put additional fan below, so that the Pi and the MCU is cooler, doesn't get hot. That's maybe another cause of why it's losing power. So I will do these two changes offline again, and then we continue again once everything is up, guys. Sorry for that, but at least it's working, it's alive, it's printing. Just now we managed to print the first layer test, but we want to try to test again for the first layer Z, and it's a problem. So we call it a day here, and then we continue in the next stream again, just so that I make sure I test everything first, the motors, and then the fan. Once it's working, we will continue again on the next stream. And yeah, I think that's the only changes that we need to make. I also need to check this nozzle, is it leaking or what? Because this nozzle that time is burning, so I don't know whether is this nozzle leaking or what. I will need to check. Alright guys, so we call it a day. Thank you for tuning in. If any of you are here left, thank you for making it this far. I'm sorry that this doesn't turn out well yet. I'm going to do the changes, especially the motors, and after that we will continue again. We will get this to be printing like before. Okay, before it was already printing, so now I don't think there's any problem except for the stepper motors, because it seems that now I try to push it more, and then I changed the position of the MCU and the Pi at the bottom, so there's no fan blowing at it, so I will need to put a fan there. Alright, so we continue again in another stream, guys. Thank you for tuning in. Have a good night, good morning, good evening, everywhere you are, and keep your best mental health. Please have the best of mental health and support open source. Thank you guys. Have a good night.